All righty. There we go. We got it. Hello, my name is Benjamin Legum. I am the Chief Executive Officer of Muse Engine. And Muse Engine is a company dedicated to simplifying manufacturing. So what do the cap to a Dove body wash, the handle to the hammer, a gear, and these personal care devices have in common? Well, they have all been manufactured with a process called injection molding. Injection molding is one of the most widely used manufacturing techniques in the world. The problem with injection molding is that it costs up to $750,000 and 1 to 5 months of time just to get your design from the design stage to the manufacturing line. So similar to 3D printers, what if you could start manufacturing instead of making prototypes the same day your design is ready? So in minutes instead of months. Muse Engine has developed a rapidly configurable injection printing process that allows us to provide true rapid manufacturing services. We have taken the pin art toy that we all grew up with and merged it with 3D printing and injection molding technologies to develop an on-demand injection molding system. With this technology, the Muse Engine business model will be to offer a rapid manufacturing service. There are endless use cases for Muse Engine's injection printing process. For example, the US Air Force has the parts for 78 different categories of airplanes and less than 1,000 of each type. Key medical device components can be manufactured quickly and at a significantly lower cost in order to get a product through the FDA or even to the FDA. And with Muse Engine, it will be possible to receive next day shipments of your potential consumer product line, such as these baby bubble tops. As an example, a regional partner of ours needed to produce 7 replacement parts for their Fortune 5 client. It took our partner 2 months of time and cost them $150,000 to develop the parts. Muse Engine would have been able to provide next day shipping of these replacement parts for a fraction of the cost. Muse Engine aims to optimize US supply chains through US-based manufacturing, US-based shipping, US-sourced resins, and most importantly, US-based intellectual property protection. This also means US-based jobs. Contract manufacturing in North America is currently a $190 billion market. Contract injection molding is nearly a $7 billion segment of this, and the healthcare space represents over 25% of this market, which represents a $1.7 billion beachhead. Muse Engine has already identified over 100,000 potential customers, and we are focusing our efforts on the healthcare sector to begin with through targeted sales and marketing, working with medical device companies and the contract manufacturers, and through capturing customers through conferences and trade shows. The bottom line is that we can undercut our competitors on time and price while maintaining quality. Muse Engine fills the niche between 3D printers and injection molding by reducing the time to get to manufacturing, by creating production quality parts, and by maintaining quick production speeds. The estimates shown here reflect the cost to make a small gear off to the left. As you can tell, Muse Engine can begin manufacturing thousands of parts at the same time it takes a 3D printer to get started for a fraction of the price of traditional injection molding. The Muse Engine has we have already submitted our intellectual property in May of 2021. We are currently expanding our team. We're looking to grow to 5 people, and we will be generating revenue with our non-automated system in early 2023, as we expect to launch our fully automated system towards the end of 2024. Our strategy to increase the value of Muse Engine is first off to generate revenue through a non-automated service, so it's 3 to 5 day turnaround for batches of 1,000 to 10,000 parts. Then we'll concurrently develop a fully automated system, which will then give us next day turnaround. Expand our profile to include sterile operations, grow our capabilities to other forms of processes, and then expand our use cases for the automated system to include metals, casting, and thermosets. The Muse Engine team is powered by product development and manufacturing experts. Dr. Jody Strausser has 10 years of industry experience as a software engineer in the defense sector before he became a professor at Clarion University. Jennifer Bondran is a technology and management consultant with 15 years of experience focusing on product development and quality management. And I am a Navy veteran with a background in manufacturing and process engineering, material science, product development, and technology management. Both Jennifer and I are adjunct professors at Temple University, where we co-teach entrepreneurial bioengineering based off of our product development technicals. Our advisory board consists of both business development and technology experts, ranging from injection molding, additive manufacturing, business development, mergers and acquisitions, the list goes on. So the key takeaways are that we are able to significantly reduce the cost and times associated with manufacturing. Next day shipping of injection molded parts, a $1.7 billion beachhead, and everything stays in the United States. We are currently raising a $1 million seed round. My name is Benjamin Legum. Please feel free to ask questions. Thank you very much for your time.
Benjamin, nice presentation. Is this your first entrepreneurial venture?
So yes and no. So both Jennifer and I have been consultants doing product development for the last 19 years. And this is the first time we've actually taken our own advice and translated it into a startup company itself. So we've built products before and gotten them to the market, but this is our first baby, if that makes sense.
Is there any IP related to this?
Yes, we just submitted converted our provisional patent to a 91-page non-provisional patent that covers everything. We even did a patentability search prior to even getting started, where we realized that this technology, it was an open space for us.
Excellent. Question from the audience. Can you make products of any materials and combination products?
So with the automated system, the answer is going to be yes. So that's actually a two-part question. So one of which, any material that can currently be used with injection molding? Yes. This is the same, at the end of the day, it's still injection molding. We have redeveloped the way the molds are being made. So we're getting rid of that hurdle, those costs and the time with making the molds. So when it comes to additive manufacturing though, so we can actually take injection molding and with the automated system and turn it into an additive manufacturing technology. So I will scooch a little further down there you go. So when it comes to additive manufacturing, if you take a ball joint, for example, we can actually do the initial injection of the ball and arm, create a secondary cavity, and then do an overmold. So we could actually do completely integrated parts that are able to have motion. So it'd be additive manufacturing from the inside out.
And here's another question. While you can manufacture it, if the quality systems required for each industry is most costly, what is your go-to strategy to penetrate the least barrier to regulatory hurdles?
So both Jennifer and I are very familiar with quality management systems. I'm ISO 13485 lead auditor certified. And then we dot I's and cross T's. So we're actually going to start with the medical device space because both Jennifer and I that's where our specialty is. We've been doing product development in the med tech space for over a decade each. So that's what we'll be doing.
And our next question is, can you show cap structure terms on the raise slide again? This person missed it.
Caps, well, we didn't actually have the terms in there. Right now, we are doing a safe note with 20% discount, and we're open to discussing a cap.
Another question is, how do you work with the client? Do you send specifications or do you first consult with them regarding their needs? Do they send specifications to you or do you consult first?
It's actually a bit of both. So right now, our initial traction, we've been reaching out to, we have some partner organizations we've been working with that have shown significant interest, where we're doing consulting on a one-to-one basis. We are currently, part of this raise is actually to get our online portal in place where people can upload their design specifications and then we can move forward. So in that case, what we're doing is We're taking our CAM software and actually converting it into a quick and dirty or quick and easy quote system. So you look at the CAD example design to the left here, our CAM software already exists, and we're able to convert that in existing CAD into the format we need for the injections to occur.
And I was just curious, is this fall under where you could apply for an SBIR grant?
For the not automated system, what we found is that, so we've been looking into that. The not automated system, people want to see that we're able to get through the initial hurdles. For the automated system, yes. So we are actively looking to apply both with NSF and the Air Force, AFWorks or AFWorks to submit an SBIR for the automated version of the system. Yes.
Excellent. Anybody else with any questions for Ben? No? Wonderful. Ben, nice presentation, nice slides. And I'm sure the country really needs what you're offering right now, considering what we've been going through from supply chain perspective. Our next presenter is Nicole Pass. Is Nicole Pass on? Let me just double check.
Hi, Mark. This is Aiko.
Oh, wonderful.